Okay, let's wrap up weather with probably one of the more interesting topics that you're probably going to be listening to me about, which is the natural hazards that we live with due to the different weather events like tornadoes and hurricanes. Both of those are highly destructive events that are a result of many and all of the variables that we were discussing in the last several topics. Now we get to kind of dive a little bit deeper into what tornadoes are, what hurricanes are, how they're measured, how they happen, how do we prepare ourselves, and how do we look out for them in the future with better prediction. So let's get it kicked off. We know that hurricanes and tornadoes, sadly, very sadly, result in the loss of life, property. They're absolutely devastating. The most recent one from the news this year was the Nashville tornado, which was absolutely devastating with 30 plus lives lost. My heart goes out to all of them, as with every tornado victim during the year, because it is a rough thing to deal with. I don't have personal experience, but I can certainly empathize with those in those situations. All right, so the energy, how do we get these things to form? Because they are like the upper level of energy being released and coalesced into one event. Now, condensation tends to be the driving engine of our systems. So when we are wrecking our air up into the cloud, up into the upper atmosphere to create clouds, that condensation is that removal of heat from the water vapor to turn it into water liquid droplets. That excess heat that leaves into the air causes the air to rise even faster and more viciously, so to speak. So when you have condensation, again, that heat is removed, it heats up the surrounding air, makes that air less dense, causing there to be an increase in what's called uplift. Okay? You can also refer to that as being the upward flow, the updraft. Okay, that's the more technical term, but just to give you a few different synonyms of how to explain that there's more uplift into the air. Okay? So the updraft then causes us to build these big clouds. And in order for these big clouds to be sustained, they have to have a fuel source. So if condensation is the engine that helps drive this thing to get bigger, you need a fuel source. That fuel source for hurricanes comes from warm air and lots of moisture. Best place for that? Tropics in the Atlantic. So from the Tropic of Cancer to about the equator, those are going to be the most ideal conditions, the most ideal environments to create hurricanes. And they start forming right off the coast of Africa, the west coast of Africa. Normally, I would say it's around the beginning of August, you start to see some tropical storms that start to formulate over the ocean as they slowly, over the process of 2 weeks, make their way over to the eastern coasts of North America and Central America, and they begin to get bigger and bigger and bigger as they're fueled by that hot, moist air. Okay? Now, the current, the ocean current, also helps to move these systems, because if it's forming over warm water and that warm water is moving this way, it needs to continually be fueled, and that warm water moves and kind of pulls it along with the planetary winds that are in that section of the planet. So we have two reasons why we got hurricanes that are going to start moving from west coast of Africa to the north, or to the east coast of North and Central America. All right. Now, if they get up maybe a little further, maybe a little bit north of the Caribbean, they may pick up the Gulf Stream and ride up the east coast and maybe eventually die out and become a tropical storm or depression for somewhere like United Kingdom. All right, where does a hurricane's path normally change? Because if we're marching across from the west coast of Africa towards our eastern coasts of North and Central America, it tends to alter its course once it reaches around 23.5 degrees north, the Tropic of Cancer. And the reason for that is we have a shift in planetary winds. So if we come here on page 14, we can see that in this region here, we're below and it's moving us slightly in this direction to the west. But eventually they start to peter out or slow down a little bit, and then they pick up the southwest winds that blow it up to the northeast, thus creating this hook pattern in the ocean. Okay. Hurricanes can be extremely devastating. You may also have heard of typhoons or cyclones, which are developed out in the Pacific and the Indian Ocean. So typhoons are typically going to be in the Pacific, and you tend to hear more about cyclones maybe in Australia and the Indian Ocean. Now, all three of those are just regional variations of the same storm, and that just has to do with historical context and people in those locations giving them names, and then all of us in science converging and realizing it's all the same thing back in the past. But most hurricanes, typhoons, cyclones can average around 100 miles an hour. We're tending to see large typhoons that can even have sustained winds, and I mean sustained as in a constant wind of 150 to 180 miles an hour. There was a typhoon with gusts as high as 215 miles an hour last year in Thailand. So these are monster storms. Okay? Just to give you an idea before we get into tornadoes, that's like a constant EF1 blowing and blowing and blowing for maybe a day, day and a half. Okay? If you're towards right at that center eye of a hurricane, where those winds are strongest. All right, normally, hurricanes are about 400 miles in diameter. They can get even bigger. Hurricane Sandy was a monster hybrid, so to speak, of a nor'easter kind of combining with a hurricane, kind of, it was all kind of late in the season, and ended up being almost 600 to 800 miles wide in diameter, so that was a monster. They certainly can be bigger. Now, for us, in order to classify as a category 1, 2, 3, 4, or 5 hurricane, we have to look at the Saffir-Simpson scale and determine certain qualities of these hurricanes in order to classify them as such. Most of the time you are looking at the low pressure and how low is it in order to begin the qualification and classification process. Then we begin to look at the wind speeds, the ranges of wind speeds that are associated with it, and then potentially if you were right at the coast, what type of storm surge would you be expecting? So all of those conditions are associated with the classification of the scale of hurricanes, called the Saffir-Simpson scale. Now, hurricanes are absolutely dangerous. They bring lots of rain, they bring wind. Okay, all those things can damage the infrastructure that we have in our civilization, our society, and cause us to maybe need to prepare a little bit for this event. Not to say that we shouldn't be preparing for the current event that we're already in, just to make sure that we have our basics met in case the damage or the danger or the threat continues for longer than we expected. Now, if we need some backup, we might need to be looking at having some food and water, maybe some batteries, generators, medical and first aid supplies. You might want to think about lighting, flashlights. You might want to think about the possibility of even some entertainment. Because if you're safe, if you happen to be safe after the event, but you're not able to have power, you're not able to have electricity, maybe something to pass the time, or maybe you're going out and helping to volunteer with others, but let's make sure the basics first are met. All right? Now, how do the hurricanes die? Honestly, that's what we like to see, is if they're going to hit land, hopefully in an area where it's not highly populated. Unfortunately, though, they tend to be highly populated areas because coasts they flourish with the ability to communicate and to transfer and trade with other parts of the world. So coasts tend to be highly populated also because it's great for vacations. So, however, if they hit land, you're taking away one of the fuel sources, which is moisture. Over land, it's not as moist the air. Also, the further in latitude you go, if the water cools down, because you're at higher latitudes, you're going to rob it of its fuel source and it starts to deplete and degrade. Now, if we tend to have an abnormally hot summer and the temperatures of the water maintain higher than average temperatures, then we could expect to see the opportunity, or I should say I would say not the opportunity, but the chance for a hurricane to make its way up the East Coast, just like Sandy did, where we had much warmer than average temperatures throughout the wintertime. If some of you recall back in the day, depending on who's watching this video, you will remember that in New York, the Botanical Garden outdoors was talking about flowers blooming in January. All right, so that was definitely an atypical winter. All right, so hurricane season tends to be late summer into early fall when the ocean temperatures tend to be highest. You have that lag period between our tilt of the earth receiving more sun, and we also have the fact that we're entering summer, which that's due to the tilt of our planet. All right, so hurricanes are dangerous, but they are relatively predictable because they're large and they take a long amount of time to cross the ocean. All right, early warning does help us. However, there are always those path differences depending on a lot of other weather variables. So it does help save thousands of lives through early prediction. All right. If you want, you can check out this large category 4 or 5 Hurricane Matthew back a few years ago if you want to see the track that was taken over the time period, which it was a long time period. All right, tornadoes. Tornadoes are usually most common in the late spring, early summer. Tornadoes are absolutely devastating, okay? We're talking about massive damage. We're talking about high winds, and in some cases, you may have a cloud to ground tornado that's 1.5 miles to 2 miles wide and as fast as 301 miles an hour. That's the record that was outside Oklahoma City years ago. I think it was in 1999. That's the record. But that is absolutely mind-numbing. It's mind-blowing of how freaking fast that is. All right, so anyways, what we definitely need to have are warm and moist air masses. We got MTs that are going to collide with MCPs, and then you're going to get devastation. You're going to get wrecked, and you're going to have these giant tornadoes. All right, the upside of tornadoes, if there is any upside to tornadoes, is that they last usually between 1 minute and 60 minutes. Depends on how fast that cloud's moving and how strong and built that radar system is showing us for the intensity of this tornado, how long that vortex stays on the ground. But we may end up seeing over that 1 to 60 minutes, maybe a path of 1 mile to maybe 30 miles. It depends on how fast, again, that system is moving with the tornado. Does it leave devastation? Absolutely. And as I said to start with this video, it is devastating. So not to be taken lightly. In terms of tornadoes, let's talk about now what do we do as people. For hurricanes, if you can evacuate and you've got a safe place, safe haven somewhere in a different location, I say go. You know, if you're taken care of, you know, I think safety and health is priority number 1. Tornadoes, if you've got a basement, get to the basement. If you don't have a basement, get to your interior room. Get anywhere you can as far to the center of your structure away from windows as you can. And if you don't have a basement, get something on top of you, cushions, mattress, whatever doesn't impede you, because you don't want to pick up something that's too heavy, but you want to be able to be prepared to grab something to protect your head if you can't get maybe under a stairwell in your basement where you have nice, strong foundations. If you're in your apartment, you want to go to the interior room because those windows are going to blow out. You don't want to be near the glass when it explodes. All right, tornadoes are semi-predictable. There's a little bit better prediction rates at this point because we've had years and years of high technology being sent in and being probed and looking at these things in higher resolution radar. They were starting to realize that there are these aspects to a tornado here where if this, let's see if I can get better color here. If this is our really intense radar, you know, the reds, the purples, and the whites where we're going to get hail and high winds. There's these little hooks of radar here. And these hooks are showing that the vortex that was rolling over in the sky, creating that convection, has now been tilted, and there's this swirling that's causing the radar to spin in that pattern, which is giving us an idea that there's an early warning for a tornado. Is it guaranteed? It may not be guaranteed, but this is a high chance, and that's why you get some tornado warnings when there isn't a tornado on the ground. All right, so there's 2 ways tornado warnings happen. Either it's imminent or it's on the ground. So you either have you got feet on the ground with an eye spotter, somebody says, I see it, call it in, or you've got a warning because you got these hook echoes, and you've got our meteorologist trying to project the pattern and a time frame by which that cell is going to reach a location so that you know and you can keep up to date with that warning system. Okay? The other thing about tornadoes is what people don't sometimes realize or haven't learned yet about tornadoes is that usually most of the rain, most of the hail, most of that stuff is past, and the tornado's on the back end. Because the front end is what fuels our storms, that updraft to feed them. But then there's a downdraft on the back side, which is what kicks those tornadoes out. Also, a precursor for tornadoes, you tend to sometimes see an olive green hue, an olive green gray in the sky. Those are the hailstone, or the hail in the sky that's creating kind of this refractory, color coming out of these clouds. So that's kind of a precursor indicator of a really rough storm coming in. If hail is dropping, hail tends to be a precursor that you have an extremely strong updraft holding these ice chunks up in the air, and that updraft holds it up there long enough until it starts falling out the downdraft side. And usually if it's that strong up, it's going to be that strong down, which means you have the possibility of kicking out a vortex and it's spinning down here into the ground. All right, so we don't have any guided practice or independent practice with this. This is kind of one of those special little videos, because you know what, when it comes to weather, we always want to know more information about the really extreme stuff. So I hope you enjoyed some of this information, and we're going to start the next topic tomorrow. But if you have any questions, feel free to leave some questions in the comments below, and I hope maybe I'll even provide a few little links below, so if you're really interested, maybe I can find a full episode on this stuff so you can watch that too for your own learning and viewing pleasure. All right, take care. See you for Climate Next. Bye.